Welcome to the VEX Classroom. My name is Jason McKenna, and thank you so much for joining us this evening for our webinar. We'll be talking about our brand new Computer Science Fundamentals course. We're really excited to show this course for you off this evening. I know a lot of teachers right now, a lot of schools right now are preparing to go back to school remote this fall or doing some type of hybrid model. And we're all looking for quality computer science curriculum. So we're really excited to show this off for you this evening and to show off how you can use VEX Code VR in our brand new Computer Science Fundamentals course in your classroom this fall. As I mentioned, my name is Jason McKenna. If you've attended our webinars before, you know that I'm the Director of Educational Strategy here at VEX Robotics. That means that I have a great job. I get to oversee all of our exciting products and help develop the educational solutions for those products, whether it's V5, VEX IQ, our two newer products, VEX Go and VEX 123, and of course VEX Code VR, which we'll be talking about a lot this evening. I'm a former classroom teacher. I taught in a school right outside of Pittsburgh, Pennsylvania, where our VEX classroom is currently located. The last couple of years that I taught, I got introduced to educational robotics, and it's really been a whirlwind since then. And that brought me to where I'm at this evening, talking to you about our brand new Computer Science Fundamentals course. Once again, if you've attended our webinars before, welcome back. If this is the first time that you've attended our webinars, the basic structure of it is I'm going to speak for about 45 minutes. If at any time you have a question about anything that I'm talking about, please feel free to ask it. You can ask those questions in any of our VEX social media channels. You can also ask it right here in the chat in YouTube. We'll have people monitoring social media. We'll also have some people monitoring YouTube to help get those questions answered for you. At the end, the last 10 to 15 minutes of this evening's webinar, I'll have the opportunity to answer some of the more prominent questions, or if there were questions that we didn't get to answer during the chat, I'll answer them during that time. So what are we going to walk out knowing today? So we have three big ideas, three big goals that hopefully you're going to walk out understanding at the conclusion of our webinar. Number one, why learn coding? So I really didn't just want to kind of jump into the course immediately. I wanted to really kind of spend some time talking about why it's important for all of our students to learn computer science. There's a lot of CS for All is a real popular initiative right now. Broadening participation in computer science is also a very powerful issue right now. So I wanted to kind of talk about why at VEX we feel it's so important for all students to learn coding. Now, with that being said, there are some challenges in learning and applying coding. That's going to be really important because we're going to talk about, when we dive into the course, how we try to address those challenges as curriculum designers and the research that goes into how to teach coding, how to teach computer science effectively. And then lastly, of course, what can you expect in Computer Science in the Computer Science Fundamentals course? We're going to go through and we're going to talk about the structure of the course, as I mentioned before, kind of the pedagogy that undergirds the course, some of the features of the course, and just some of the real cool ways that we try to create student engagement, make it easy for you, the teacher, to actually teach the course. All right, so lots to cover tonight. Really excited about this course. So let's start by talking about why learning coding is so important for our students today. Number one, and this is probably the one that we mostly think of when we think about teaching coding and computer science, is develop 21st century job skills. So I think most of the people attending the webinar this evening, if you're teaching VEX, if you're teaching STEM, you probably hear a lot about the fact that there is really a shortage of people entering STEM careers. There's a shortage of people entering computer science. There's a real need for more software engineers, more people entering those STEM types of fields. And that's obviously true. That's obviously important. But it's actually more than that. So if you think about the fields like science and math, over the course of the last 10 to 15 years, each of those fields has developed a very large computational component. What that essentially means is nowadays, if you are a professional mathematician or if you're a scientist, there is some aspect of computing or coding within your job, within your field. So one of the things that we try to do a lot in education is show students, the authenticity of what they're learning. Teachers never like to answer, like, when am I ever going to use this in my life, when a student asks that. When we think about 21st century job skills, it's not just what we would sometimes think of someone who's coding all the time, but as I mentioned, professional scientists, professional mathematicians. There are entire fields like computational biology that didn't exist, 5 to 8 years ago. All those things have been created as a result of computer science, as a result of computation. So it's important that our students recognize and understand that. I have a personal example of this. My daughter wants to be an astrophysicist. So, me trying to be a good dad, you send her off to different camps during the summer to learn more about it. So she went to a college. The camp counselors at the college were all people studying to be astrophysicists themselves. So my daughter asked, as I'm in high school, what should I do to help prepare if I want to go and become an astrophysicist? And all of her counselors at that camp told her the exact same thing. They told her, learn computer science, specifically learn Python. We didn't know that when we started our program here at college, and those that did, they were able to accelerate much faster because, analyzing all the data, all that's done via programming right now in that particular field of astrophysics. So when we talk about how those fields have changed, unfortunately, our high school classrooms, science and math, really haven't kept up with that change. So this idea of developing 21st century job skills, it's not just about coding, it's not just about engineering, that's a big part of it, but really how those things have impacted all of our lives. Secondly, exploring the high-tech world around us. This is another really important point. If you think about the fact that students nowadays in schools, and every high school across the country, they're going to take biology and they're going to take physics, but it's not the expectation that all of them are going to be biologists or all of them are going to be physicists. Instead, we want the opportunity to teach these students about the world around them. Well, computer science is ubiquitous in the world around us right now, so it's really becomes upon us as educators to make sure that our students are informed citizens in the world, and a big part of that is understanding and learning computer science. A great example of this actually happened back in 2019, and that was when we're able to create an image, capture an image of a black hole. And I remember this, and everybody was excited about this. I remember seeing this on the Today Show. This was front page of New York Times. The thing that wasn't talked about as much was the fact that Katie Bauman, and Katie, I'm sure you're watching this evening. I hope I'm pronouncing your last name correctly. I apologize if I'm not. But Katie Bauman, she was the one that developed the algorithm so that we can actually do this, that we can actually capture this image of a black hole. Now, when I was in the classroom, these were things that students would bring up and talk about all the time. Hey, Mr. McKenna, did you see on the news last night that we were actually capturing an image of a black hole? I remember learning about that. Black holes last year in science class. Isn't that cool? Isn't that fun? But imagine now if you can extend that conversation further and talk about the fact that an algorithm was the thing that was able to enable us to do that. So what is an algorithm? What did they actually do with that algorithm? As educators, we know that learning happens all the time. It doesn't just happen from bell to bell. It happens all day, every day. And those moments in the classroom, you're able to have those types of discussions with your students, whether they're around current events or something else. Real learning takes place during it. But unfortunately, how many of us teachers were able to talk about the fact that that great discovery, that image of that black hole, was done with Katie Bauman when she created an algorithm? That's a great conversation. That's a great example of being able to explore the high-tech world around us. So once again, just like we're able to teach biology, just like we're able to teach physics in order to teach the students about the world around us, obviously algorithms and AI and computational thinking, these are a big part of the world around us. The last thing when we talk about why learn coding is this idea of bringing your own digital creations to life. Once again, this is kind of, as I talked about in the first one, this is kind of expanding what we would normally think of with computer science. With computer science, obviously, once again, coding is a big part of that. But if you think about your favorite movie, if you think about animations, if you think about just art itself, a lot of that was developed with the help of computer science. Once again, I have a personal connection to this because a lot of the people that work in this office, the ones that make the animations that you're going to see in our computer science fundamentals course, the person that made this poster for me, these are 2D and 3D artists that use computer science every single day. So whatever we might think, how we might identify when we think about someone that writes code, we really need to expand that for our students and show them all the different ways that you could be creative and all the different things that you can create when you begin to learn computer science. Obviously, everything that's going on with the pandemic right now is just absolutely terrible. Whether everyone getting what's happened to our school systems as a result, the massive impact we've had on the economy, obviously the massive impact it's had on people's family, with people getting sick as a result of it. But one thing that has also happened as a result of the pandemic is most students in the U.S. are finally getting to go one-to-one with devices. Whether it's a Chromebook, it's an iPad, or whatever that particular thing may be. And the opportunity that comes with education is we have a chance to show students that those devices that they're getting, those computers, those Chromebooks, iPads, whatever it may be, they're not just tools, but they're also mediums. Just like writing is a medium. When I taught writing when I was a teacher, we didn't just teach writing for the sake of writing, but we also taught writing so you could learn about other subjects. We taught writing so you could express yourself with poetry, short stories, novels, whatever. Computers and computer science also give you that same opportunities. You can create with it, and you can create just about anything that you want with it. So students have the opportunity to do it. Most of them have devices right now. And this is another key part about why teaching and why all of our students should be able to learn coding to help bring digital creations to life every single day. Okay, so it's really important when we talk to our kids about why they should learn coding, why they should learn computer science. It's not just framed around, hey, you can use this to get a job. That's obviously important to a lot of parents. But if you're talking to a 12, 13, 14-year-old, that's not a real impactful way to describe to them why it's important to learn computer science. It's part of it, but it's not the whole thing. Talking to them about how they could not just be consumers of technology, but also creators of technology. Talking about how they can learn more about the world around them. Talking about how they can use coding in order to be expressive and create things. Those are much more impactful ways that we can talk about coding and we can talk about computer science with our students. Okay? Secondly, what are the challenges in learning coding? Once again, this is important because this really informs a lot of the decisions that we make and a lot of the things that go into our computer science course. And there's a lot of misperceptions out there around the learning of computer science. So it's important that we kind of talk about them and combat them head on. So we talk about the challenges of learning coding. Probably the two biggest challenges, number one, is that students conflate spoken languages, as I'm speaking to you right now, and computer languages, all right? Computer languages, if you're trying to communicate to a robot, so I have, like the 1, 2, 3 robot right over here. If I'm trying to communicate and have this robot do something, I have to break down that task into the smallest possible parts that I can. We refer to those as behaviors. And then I have to try to match those behaviors to the individual programming blocks or the programming commands themselves. That is a large part of computer science. It's a large part of coding. In spoken languages are full of inferences. So I can tell someone to walk to the door and that person will probably just walk to the door and stop, even though I did not specifically tell them to stop. Well, in a computer language, you have to specifically tell the robot or the computer exactly what you want it to do at all times. And that's a big hurdle for students to be able to overcome when they are first introduced to a programming language. And we'll talk about in the curriculum how we try to combat that. Secondly, to go back to the example I've used a few times already this evening, the idea of, if I'm teaching high school biology, when those students come into the classroom, they have a lot of background knowledge about the world around them, which is what they're studying in biology, whether it's around the water cycle, different landforms, whatever those particular things are. Those students have a lot of background knowledge. When students come into a computer science classroom, most of them do not have any type of background knowledge around computing. Now, this is the key difference. A lot of people think that because a student has had an iPhone for years, or because they've used an iPad for years, that there is a transfer between that and actually creating technology with an iPhone or an iPad, but there's not. So being able to use a device and being able to create with the device are two entirely different things. So just because someone has used a device, it does not mean that they are going to be able to create or code with that particular device. That's a very important thing, and that background knowledge is what they lack. So it's our job as educators and it's our job as curriculum designers to help be able to fill them in with that background knowledge. Another big challenge that you have when first teaching computer science and teaching coding is it's a very new subject. The example I say with this all the time is, once again, when I was teaching and I would travel to elementary buildings, first of all, everyone knew, the teachers knew, even if the teacher didn't have that particular student in their classroom, the administrators knew, the parents know. If you're a first or second grader and they're struggling with sight words, you know that's a problem, because you know that there's a benchmark for that age for students to know certain sight words. Just like you know, by the end of third grade, all of the students should have their multiplication facts, 1 through 9, memorized, so they can then go on and use that fluency to learn more complex mathematical topics later on. Those benchmarks currently does not exist for computer science. That learning progression does not exist for coding. So at the end of 5th grade, what should a student be able to identify that sequence is a key part of an algorithm? I mean, those are the things that aren't widely accepted or widely adopted in computer science yet, that exist in our other core academic subjects, once again, like math and reading. So that is just more of a, more exposure to computer science, getting more curriculum like the one that we're going to show you this evening with computer science out there. That's really what you have to do to be able to combat that. It's really just more of a challenge of broadening participation and doing more professional development with teachers so that more of them understand the way and the progression that students actually learn computer science. Okay, so we've covered our first 2 topics already this evening: why learn coding and the challenges of learning coding. So we're going to talk now, we're going to transition to what you can actually expect with the Computer Science Fundamentals course. Before I dive in, though, and I know there's a lot of people probably anxious to see it, there's 2 things I want to kind of just get out right now, because we'll probably have questions about it already. First of all, this Computer Science Fundamentals course that I'm going to show you momentarily is going to be free for this school year. So this is the decision that we made at VEX, because we know, once again, there's a lot of schools going back remote at the beginning of the school year, or you're doing something hybrid. You're searching for content and easy ways to be able to teach subjects like computer science. So this course is going to be free for this upcoming school year. I mentioned this during the webinar last week, but it bears repeating here again this evening. Also, VexCode VR is going to be free for this upcoming school year. So both things that I'm going to show you here this evening, VexCode VR and then how it's used in our Computer Science Fundamentals course, both of these courses are going to be free for you as teachers during this upcoming school year. We know schools are really hurting right now, teachers are hurting right now, so hopefully this can help ease the blow of everything that you're trying to do and everything you're kind of suffering from at the beginning of this school year and as we go back to school. So VexCode VR, we've done some things for you to hopefully make it even easier for you to implement as you get into this school year. So I'm going to go ahead and open up VexCode VR now and go ahead and show it to you. So if you haven't been in VexCode VR for a few days, this initial screen might surprise you. So what we've done here is we've added this new dialog box with what's new. So if you are someone new that's just logged into VexCode VR, I shouldn't say logged in, you just launched the browser, vr.vex.com, because it is web-based. You can see the 2 newest things that we've added here. The first up top, we talk about Python support and how you can use that. The Learn More button there takes you to a knowledge-based article that talks about how to start a new project in Python. The second bullet that we have there, talks about our actual Computer Science Fundamentals course, okay? So I'm going to go ahead and close that. If I go ahead and I open this back up again, this is not going to be there. It won't pop up every single time that I launch VexCode VR on my browser. The other thing that you'll notice here is that we have a tutorial video loaded when you go and you launch VexCode VR. The reason why that we wanted to do this is because we know that there's going to be a lot of new students using our Computer Science Fundamentals course and using VexCode VR in this upcoming school year. So hopefully by placing that Getting Started tutorial video, when students first launch VexCode VR, they'll see things like, oh, here's how they can access the help. Here's how I can drag a block into the programming area. Here's how I can delete a block. Here's how I can make my robot move forward. All those real basic things. So essentially, you, the teacher, do not have to do that scaffolding for the students as they first begin to use VEX Code VR. Instead, that getting started tutorial video, which will be right there on the screen for you when you get started, that will exist. So hopefully that will eliminate some of those questions for you from your students. So as you can notice, just with all of our tutorial videos, I can go ahead and play it.
With VEX Code VR, you can program a VR robot to do many
larger
things.
if I want, but I'm going to go ahead, I'm going to close this. Another thing that I'm going to show for you right now is if I go up into the File menu, and now if I click About, you're going to notice this is a new screen that we've added here in the File menu. And what this shows is, first of all, that my version of Chrome that I'm currently running on the computer supports Playgrounds. So some of the questions that we received when we first released VEX Code VR back in the spring of this year was, my Playgrounds aren't loading. And that was essentially because they were using an older browser and had poor internet connectivity, things of that nature. So now, instead of, once again, you having to answer that question for the students, we've put some information in here to help the students and you troubleshoot much easier. The other thing that we've added on there is you can see the button down there where it says to clear the playground cache. And what that then does is that, once again, will help you to be able to load the playgrounds. That was one thing that we saw often that students had a hard time with when they first opened up VEX Code VR. Everything that I just talked about right now is in this knowledge base article that we just published today, troubleshooting playground loading issues. Once again, this was really the only problem that we saw with VEX Code VR, so we don't want you, the teacher, to have to troubleshoot this. Instead, we want students to be able to troubleshoot this on their own. So you can see troubleshooting issues. Loading a playground might get stuck because the files are still downloading due to slow internet connection. Devices loading the playground may be an error on a slower device, kind of so on and so forth. So we walk you through how to do this on different browsers here, and we walk you through how to use that About screen that I just mentioned to you right there. So once again, we do not want you, the teacher, to have to troubleshoot issues when students are just getting started with VEX Code VR. That article that I just mentioned to you right there is in our knowledge base right now. You can give it to your students before they actually start the course. It's a great way to, once again, eliminate any problems that students might have when they're first getting started with VEX Code VR. Now, with all that being said, all the benefits of VEX Code VR that we always talk about are still there. So one of the reasons why VEX Code VR is a great way to teach computer science is, as you can see here, I can get started very quickly. I can drag one block in. I can hit the start button. It's going to load a playground for me, and I'm going to be able to see my robot run immediately. So within seconds of launching VEX Code VR, I am able to get my robot to run, and I'm able to get that immediate feedback. And that's a real powerful learning tool for students, being able to do that. Once again, VEX Code VR is web-based. So if you are one of the students or teachers that are giving out Chromebooks to kids, you won't have to worry about them having to download an app or upload an app. It's complete and totally web-based. With the About screen that I showed you a moment ago, it's real easy for you to tell if the student's browser supports the playgrounds in VEX Code VR. So accessibility is really, really easy with VEX Code VR. And then to be able to launch a project and get started with the project really quickly is very, very easy to accomplish with VEX Code VR. So we talk about the ability to give immediate feedback, the ability to make learning visible. All those things are possible with VEX Code VR. One of the things that I'm proudest about, and I believe I mentioned this during last week's webinar, is the fact that VEX Code VR, as of today, we've had over 10 million projects run. What that means is students, it encourages experimentation and encourages play with students as they are engaging with the software. Unfortunately, in education, a lot of times we feel like there's this false dichotomy between learning and play. And really there isn't. When students play, they're engaged. They want to troubleshoot. They want to find multiple solutions. They're very, very engaged. And that's what we see with VEX Code VR. our stats also tell us that an average session on VexCode VR is around 50 minutes. So this is not a situation where students are just going on to VexCode VR and they're leaving immediately. Instead, they are staying on because, once again, it's very simple, very easy to get a project running. It's very easy to get immediate feedback, to change something, see something else happen with the robot. That edit to execution cycle is very, very compact. It allows those students to get immediate feedback. It keeps them engaged and allows you, the educator, to give students immediate feedback on what it is that they're doing. So this is why we feel VexCode VR is a terrific tool to use in our introductory computer science course, as I mentioned to you, Computer Science Fundamentals. So without any further ado, let's go ahead and go there. This website is live right now, so you can go to cs.vex.com and see our Computer Science Fundamentals course. You can also get there from VexCode VR. We added a new icon in the toolbar, the little Learn icon at the top. You can click on that. That will also take you to cs.vex.com, where our Computer Science Introductory to Computer Science Fundamentals course is located. So if I go ahead and scroll down here, this is kind of shows you our vision of computer science that we have here at VEX. Obviously, we feel it's important for students to get started with VEX 1, 2, 3 to have that hands-on experience. We feel it's really, really important. I did a webinar a couple months ago, and we talked about how the most powerful way to teach computer science and STEM is the combination of physical and virtual robots. So VEX 1, 2, 3 is a great way to introduce young students, even pre-readers, to computer science. We'll have a webinar on VEX 1, 2, 3 here in the upcoming weeks, so stay tuned to VEX social media for that. Then we get into our Computer Science Fundamentals course. As you see right here, a lot of great information contained inside of it, key benefits of it, all located right here. You can see that this course spans multiple grade levels. And the reason why that is because we really feel like this course is a great introductory course no matter where your students are. If your students are in 3rd or 4th grade, if your students are in 8th or 9th grade, no matter where they are, this is a great introduction to computer science within this course. So that's why that bar spans so many grade levels to be able to do that. Now, in the future, as you can see here, we're going to do a computer science progressions course. That particular course we'll dive into some more advanced topics, still using blocks, things like variables and my blocks, things of that nature. But then we'll make the transition to Python, make the transition to text in our computer science course using VexCode VR. Our 3rd course, our computer science exploration course, this will be a full-on Python course. This one is geared more towards high school, as you can see by the particular grade band there. Those courses are, once again, not available yet, as you can see here, coming in 2021, but our Computer Science Fundamentals course is available right now. And then finally, of course, we have our educator certification courses, which span the entire spectrum, K to 12. We do have right now our VexCode VR educator certification course, which we have ready to go right now. So if you are looking for some professional development to implement this course this fall, you can go there right now. It's completely and totally free, certifications.vex.com, and you can start getting professional development in this course. Now, one thing I do want to mention about that is that if you've already gotten certified, we've had a few hundred teachers get certified in the course already. We are going to add some more sections to the course to help with implementation, especially this fall with remote learning, hybrid learning, all those particular things. Don't worry though, you don't have to go back and retake a test or anything else like that. And you also won't have to go and try to search for the new materials. In each unit in the certification course, we're going to add one new section, which you'll be able to go and see, which is just going to be some of the new resources that we're going to provide if you're looking to teach our course once again this fall. If you have not gone through our certification course yet, I would highly encourage you to do so. It's self-paced, it's online, you can learn at your own speed. All that is included in there, and once again, it is free, okay? Real quick, before I kind of dive into the course, just at a high level, I do want to share with you, like basically our goals with this curriculum, like what it is that we were trying to accomplish with this curriculum. Number one, broadening participation in computer science, more equity in computer science. This is a big topic right now in all aspects of education and specifically in computer science. How we want to be able to do that is making sure that we provide a curriculum that is built the correct way, it is backed by research, and everyone has an opportunity for success. If you look at some of the challenges that exist with a lot of computer science curriculum right now, they try to do too much. It's not that well scaffolded. We don't do those things. So we want to make sure by how we've built the curriculum, it gives everyone an opportunity to have success built within the curriculum. So just like with all good curriculum, that opportunity to have success really comes through well. So we want to make sure that we're able to broaden participation. We want to make sure that we're able to make a curriculum that is backed by research. And we also want to make sure that we make a curriculum that empowers teachers with our free professional development. And we also want to make sure that we create a curriculum that allows students to be involved in engaged learning experience. So I'm going to go ahead and dive into the course now and show you how we go through and we do all of that. Okay? So our computer science fundamentals course is 9 units, okay? Just can't kind of give you like a brief overview of all the units that are included in it. Introduction and fundamentals in the first unit. Here we talk about very simple things like block shapes and their meaning, how to stack blocks, why blocks are different colors, basic things like that. In unit 2, we get into very simple things like moving your robot, how to sequence the drivetrain commands and do things of that nature. Then we introduce the pen in unit 3. We start talking about repeating behaviors and doing and how I can make shapes on my playground. Then unit 4, we start investigating more sensors. We talk about how to navigate a maze with the bumper sensors. Then in unit 5, we also talk about how to navigate a maze with the distance sensor. Unit 6, the location sensor. Unit 7, now we begin getting into some more advanced computer science topics like conditionals and loops. In Unit 7, as students begin using the eye sensor to make decisions based upon color. In Unit 8, the Disk Mover Challenge, now we're going to get into some more advanced topics like nesting loops. And then finally in Unit 9, we're going to do the Dynamic Castle Crasher, and we're going to use that to frame the discussion of algorithms and what they are, what they entail, and how you can actually create an algorithm and what an algorithm actually is. So that's the basic structure of the course. One of the things that you'll notice about the course is that we don't try to cover too much. We believe in depth, not necessarily breadth. So we think that the biggest sin that you can make in curriculum development is developing a curriculum that is, an inch deep and a mile wide. We don't want to be able to do that. Instead, we want to make sure that we have depth in our curriculum. So we introduce topics and we're able to actually go through and cover those topics fully instead of once again just kind of covering the topics superficially. So that's a kind of like a high level view of what the course is. I'm going to go into just Unit 3 to kind of show you how the course is actually set up and how the course actually works. All of the lessons all the units that we have in the course are set up the same way. So you have a unit, the unit is then broken down into lessons, and then you have a unit challenge at the end. Now the idea here at the very beginning, you'll see we'll have a video. And what we're doing with the video is we're trying to create a shared goal. And that's really important in education because what we want to do here is we want to make sure that the students and the teacher are on the same page with what we're actually trying to accomplish with this unit. So here we have an introduction to the concepts the students are going to be learning. They're going to be learning about the pen in the unit. And then we go through at the very end of this video and we talk about how this, we then talk about how this is going to be the challenge that the students are going to solve at the end. So we have a shared goal. We introduce it here with this video, and then we connect it at the end. Now, that's really important from a pedagogical standpoint. You can see the chart that I have here. A very important part in computer science curriculum is this idea of establishing, once again, a shared goal with the students, okay? This allows you to make sure that the students and the teachers are both on the same page. What the curriculum then gets into is this idea of direct instruction. And this is really important, okay? What we want to make sure is we present the students the knowledge that they need, because once again, the students do not come into the classroom with a lot of background knowledge. So as I go back to the course here, after we do the introduction with the lesson, all of the instruction is located right here within the course. So you, the teacher, do not have to deliver this direct instruction to the students. Moreover, you also don't have to be the curriculum designer. So if I want my students to achieve these learning outcomes, we don't expect you to break down those learning outcomes into smaller conceptual chunks, sequence them the correct way, embed the formative assessment, all those particular things in there. Instead, we've done all that for you. So this entire course is student self-directed, and that means it's also student self-paced. So students are able to go through this course on their own. And that's really important, because if students have a question, and if you're talking to the students and you're the one delivering direct instruction, students oftentimes aren't going to raise their hand and say, hey, can you please repeat that? I didn't understand it. Or can you please go over that again? Or can we discuss that one thing that you brought up a few moments ago? Instead, the students are probably going to sit there and be confused because they're embarrassed to ask those particular questions and call attention to themselves. Here, because of the way the course is constructed, students can go through at their own pace. They can review things, they can go through things faster, whatever that is, because all the direct instruction is once again contained inside of the course itself. So that's really important, as I mentioned, for a couple of different reasons. You, the teacher, do not have to deliver the direct instruction. Secondarily, it allows students to learn at their own pace. And we know students lack background information when they come into our computer science classrooms. So as a result of that, we want to make sure that students have the opportunity to learn at their own pace and learn and differentiate the instruction on their own. What it mentions down here now is you talk about the foregrounding of skills. And that's another really important part that we built into the course. We talked about broadening participation. If you're able to control frustration and risk within the curriculum and how the curriculum is designed, you're going to allow more students to be successful, which is going to lead to more engagement. Okay, so making sure that the skills are very purposefully sequenced and making sure that everything is foregrounded allows students to have success with what it is that they're learning and what it is that they're doing. That helps to drive engagement. That helps to broaden participation with what it is that the students are learning. So once again, all the direct instruction is located right here within the course. But not only that, all the formative assessment is also built into the course itself. So you can see here, once again, I'm walking through the course. We're showing the students how to build the program that they need so they can build a square on their screen, walking them through the entire process once again. And then at the very bottom, as I move on to the next part of the lesson, now we have the lesson 1 mini challenge. So this is formative assessment that's built into the course. And then what this does is this allows students to monitor their understanding as they're going through the course. This helps you, the teacher, to do the same thing. So one of the things that we talk about is because of direct instruction and because the formative assessment is all built into the course, this allows you, the teacher, to actually be a facilitator in your classroom because you don't have to deliver the direct instruction and you don't have to deliver the formative assessment. It's all built into the course for you. This allows you to become a facilitator. You can assist maybe those students that need more assistance. You can give more challenges to those students that give more challenges. And this is really important now because of distance learning, because of hybrid learning. You're not going to have the opportunity to deliver the direct instruction to monitor student progress on their own. Instead, we've built all of that in the course for you. So once again, you don't have to do it. It's built inside of the course for you. So we talk about the second part, once again, the research that kind of undergirds everything that we have in the course. The coding mini challenges, the lesson quizzes. So below the mini challenge, here's the lesson quiz itself. This actually opens up into a Google Doc. So therefore, if you wanted to make changes to this, you can make a copy of it. You can make changes if you want. If you want to add questions, take away questions, whatever those particular things are, you can do that. But the other really nice thing about this is this idea of worked examples. This is a very important part in computer science research and how students learn computer science, is providing them with high quality examples of how they should actually be building a program and what they should actually be doing. We have that throughout our entire course, this idea, once again, of worked examples where we give the students the code that they need in order to be able to solve a challenge. Here's a great example right here. This is from a subsequent unit in the curriculum. Going through and explaining to them in this particular lesson, here's why you would not want to use a wait until block for this challenge, because it disrupts the project flow that you're actually trying to do. But instead, you can use multiple if statements, because this is a better example of project flow that you would have in a particular project as you are going through. All of these examples are located inside of the curriculum itself, so you don't have to do this. You don't have to create these examples. Instead, they're located inside the course. So these worked examples is a big part of the direct instruction that we provide for the students in the course itself, to give them examples of high quality instruction that they can then apply when it comes time for them to create their own solutions, okay? This is, once again, the computer science literature is very, very clear on this. Establishing a shared goal, providing students with the direct instruction, within that direct instruction, giving them things like worked examples, and then embedding the formative assessment throughout so students can monitor their understanding, they can check their progress. This is a very important framework in order to be able to create a high quality computer science curriculum to achieve those goals that I talked about a few minutes ago. Broadening participation, providing engaging and learning experience, empowering you, the teacher, by allowing you to be a facilitator in your classroom. That's how we've built all that in the course, so that you can do that and that you can be successful as you're going through and you're teaching computer science. Another example that we have that I really enjoy here, this is an example of how we kind of dive deep into the concepts, into the topics that we're doing. This is an example of the different sensors. So we first introduced the bumper sensor to the users. After we introduced the bumper sensor, we then get into the distance sensor. So what you can see here, what we're doing is we're showing you the advantages of each sensor and why you would want to be able to use a sensor. Now this is really important because, once again, we're not just trying to show the sensor and showing you how to use the sensor, but we really want to spend a lot of time talking about why. Why would you want to be able to use a sensor? What would make the best sense to be able to do that? You can see all of that in there. And the reason why that's so important is because what we want to be able to do is we want students to give them the ability to think conceptually about their solution. The research around computer science education is very, very clear. Oftentimes we try to introduce topics too quickly to students, and we don't give them an opportunity to think conceptually about what their robot is doing and what their project is doing. Instead, they essentially guess and check their way and find a solution, and they don't really learn anything. Just because a student used a variable in their project and they used it successfully, it does not mean that a student understands what a variable is. So when we talk about this idea of applying what they've learned and think conceptually about a solution, that's really, really important. And we accomplish that by giving them the different worked examples throughout, but also, in addition to that, all the scaffolding that we provide for them, we eventually then take that away, and then they apply that when they get actually to the unit challenge at the end. So we talked about this at the very beginning with this idea of a shared goal. This shared goal, that's the summative assessment that we have at the end. Now the students have been given all the skills that they need to know and they need to have mastered, so they can go and they can apply it when it comes time to do this unit challenge at the end. We have a video here that shows what the solution should actually look like. So once again, the students and the teachers are on the exact same page. We don't give them the code for the solution, but we show them what it should look like so that everyone is on the same page for what it is that you're trying to achieve. In addition to that, we also have a summative assessment located right here at the end of the particular unit to go through and show them what it is that they need to know. One other thing I do want to show you is this right here. As we get into the more difficult units, as students are starting to learn more difficult content, We include these labels inside of them. The technical term for this is sub-goal labeling. There's been a lot of recent computer science literature about how these are effective in teaching students computer science concepts. This is another great example of forcing the students to think conceptually about what it is that they're doing in their project before they actually begin coding. We force them to do this by making these comments. And then after they make the comments, they provide the necessary blocks underneath. And once again, what this is doing is asking the students to think conceptually about the solution as opposed to just guessing and checking their way to the answer. This layout right here, this is a great framework that we talk about how you can design a course, how you can build a course to hit the curriculum goals that we talked about. We want to make sure that we do is backed by research. We want to make sure that we're able to broaden participation in computer science. We want to empower teachers by allowing them to be facilitators in their classroom, by giving them the formative and summative assessment that they need. And we want to make sure that we're providing students with engaging learning experiences by making sure that we control frustration and risk by having a carefully scaffolded sequence of learning skills that students can build in between each lesson of a unit and then also from unit to unit itself, okay? Very carefully constructed curriculum based upon years of research that we've done, other computer science research that's out there. This is one of the reasons why we're so excited to share this course with you, because we feel like this is a great way to achieve those curriculum goals that we've discussed. Now, of course, that's not all that you as a teacher need in order to be able to successfully implement a curriculum. You might be asking yourself, okay, well, what about the standards alignment, or what about answer keys and things of that nature? Don't worry, we have you covered on those things also. So I'm going to go ahead and show those to you real quick. You'll notice here at the top of the screen, Computer Science Fundamentals, I can click on Activities and Resources. You can see here I can then select Computer Science Teacher Resources. Now, you will have to be logged into the Teachers Portal to be able to see any of this. To sign up for the Teachers Portal is completely and totally free. You can go ahead and there's a knowledge-based article that walks you through the process to be able to do that. But it's very easy to be able to get into the Teachers Portal. Here you'll see this is the standards mapping right here. So click on the United States. And this shows you the CSTA standards that this curriculum is aligned to, a description of the standard, where the standard is hit, and then how the standard is met. So not just going through and showing you, like just listing a number of standards, but in addition to that, showing you, where the standard is actually achieved in the curriculum, okay? So we have that located in here for you. In addition to that, we have an email home. That is a way for you to communicate to your parents about all the great things that they're going to learn in your Computer Science Fundamentals course. This, once again, is a Google Doc, so if you want to change anything on here, you just have to make a copy of it, and you can go ahead and do that. This gets into a lot of things I talked about at the beginning about like why learning coding. Why learning coding is so important. This is a great way to communicate with the parents. So we want to make sure that you have that opportunity to communicate with the parents, which is why we want to provide that email home for you. And then lastly, of course, the answer keys. So here's the answer keys for all the quizzes, the lesson quizzes, and then the unit exams. And then here are the challenge solutions right there. So all the mini challenges that we have in the course, and also all the unit challenges that we have in the course, all of those are located there for you. So as a result of that, these are some of the resources that we've created for you to hopefully allow you to be successful as you go and implement the course. All of that is in addition to the certification course that we have, which is also, once again, completely and totally free, that you can go to certification.vex.com and you can be able to go and do. So, all right, so I went about 5 minutes too long. That's okay, I got a lot to show you, but I'm gonna go through and answer some of the prominent questions that came up during the course of the chat. Appropriate grades, once again, we feel like this is a course that can be used as an introductory course no matter where your students actually are in their path of computer science. You might be asking yourself, well, how can you have something that could be taught to a 5th grader but also taught to a 9th and 10th grader? Well, the reason why that is simply because students can obviously learn through different paces they go through it. The fifth grader might not get through the entire course, might just do the first couple units in the course, whereas a 12th grader can get through the entire course and be able to do that. In addition to that, something else that can sometimes be a little bit controversial is, can I introduce high school students can I introduce them to computer science through a block-based programming language like VEX Code? The answer is yes. You can absolutely do that. The literature is very, very clear on that. Students learn computer science concepts well, like algorithms, decomposition, debugging. Those things are learned very, very well when they're introduced via a block-based programming language. That allows them to get through and be able to do that and do that well. So once again, on the home page, I'll bring that up again for you. You can see we kind of show the recommended grades that we feel like this course can hit and this course can hit well. Number of hours for the course. This course, we feel comfortable saying that it would take you at least 9 weeks to be able to get through if you were teaching, of course. Of course, we know all students learn at different paces. Some students might be able to learn faster or shorter than others. We have the VEX Code VR activities to help differentiate that instruction, and we are adding, as I mentioned a little bit earlier, some more material to our certification course to talk about how you can use those VR activities with this course if you have students that might need a little bit extra practice, if you, the teacher, want some more assessment, if you have students that need some more challenge, do some things of that nature. Those are all ways that you can use that with our activities with the course that we have here. So once again, there's a lot of content in this course. This course would probably be 9+ weeks for you to be able to teach, but every classroom is different, every teacher is different, every teacher style is different. Even though the course is designed to be student self-paced, some people might be able to go through the course at their own speed, at their own way to be able to do that. Whereas other teachers might want to teach it, more of a whole classroom approach to be able to go from there. Another questions that we got: video lessons, very text heavy. I'm not sure about the very text heavy. We do have a lot of graphics in the course. We do have some animations in the course. So I think if you have an opportunity to go through the course, you'll see that the course is not simply walls of text. We have a lot of images to show things like project flow, to show how the value the values of sensors can change as you move through an actual program. But in terms of video lessons, stay tuned to VEX social media. We'll have some more information about that upcoming here in the near future. I don't really want to get into it more than that, but stay tuned to VEX social media. If you're not signed up to the VEX newsletter, go ahead and do that. You can go to newsletter.vex.com and be able to do that. But once again, this classroom that you see here, it's not going to be used just for webinars. The idea of adding some more video-based lessons into the curriculum like you see here with the CS Fundamentals course, that is something that we will be doing. But stay tuned to VEX social media for more information on that. And also for more, we'll probably have a webinar to talk about how to be able to do that also. And that's also something you're not going to have to wait 2 months for. Okay, that's something that we're actively working on to get out for you right now. Okay. Question about how long each individual lesson is. There's not a specific time frame for each lesson. It just really depends upon the concept that we're trying to teach in that particular lesson that we have right there. So each lesson is not, once again, itemized to be a half hour or 45 minutes or things of that nature. It really depends upon what you're trying to teach as you get into. As we get into some of the later lessons within the course, obviously the lessons are a little bit larger than they are in the smaller ones at the very beginning. Okay. Trying to think if there are any other questions that we have. Just a couple other things. They're queuing up a couple other questions for me here. But once again, the certification course that we have for it is completely free. Really, a lot of this information that we're talking about with it, some of the questions that you have are located on there. If you do have more of these questions, please feel free to contact me. As you see right here, there's my email, there's my Twitter address. That'd be a great way to be able to do that. We got a question about RobotC, RVW, and VEX Code VR. The reason why we created VEX Code VR and we did not augment or change RobotC and Robot Virtual Worlds was because of accessibility. VexCode VR is 100% browser-based, which we cannot do with Robot Virtual Worlds and we cannot do with Robot C. If you're using Robot C and Robot Virtual Worlds, you're using a Windows machine. Unfortunately, most classrooms right now use Chromebooks or they're using iPads, using those devices like that. So we wanted to make sure that we created a solution for you that you were able to use on any device. Once again, what are our goals? Our goals are about broadening participation. We want schools in rural areas. We want schools in inner cities to be able to use this no matter what your internet connectivity is. We want to be able to handle that. So as a result, we built this solution from the ground up. We started from zero and built it instead of augmenting something from Robot C and Robot Virtual Worlds in order to be able to provide you with a solution that you need so that no matter what device you're using, Chromebook, iPad, whatever, you can go and you can use our course, and you can also use VexCode VR in order to be able to access the course and be able to solve everything that is inside the course, okay? One thing I do want to show you real quick, I talked about cs.vex.com. You can also get here from education.vex.com. So I'm going to go ahead and put that in real quick and show that to you. We just added this today. Literally about an hour ago, this got published. But you notice up here for the STEM labs, it says computer science, and also down here, computer science courses. So if I click on that, it takes me to the cs.vex.com site. So you can either get there from education.vex.com, or you can also get there to cs.vex.com to be able to get all of that. Also, to be able to launch vr.vex.com, all you have to do is just type that into your browser, vr.vex.com. There is no download needed. There is no install needed. You'll be able to access that right away and be able to launch that, once again, no matter what device you're using. But what we want to be able to make sure that we did is provide different ways that you can access the CS Fundamentals course that was easy, obviously both for you, the educator, but also for your students. Okay, we wanted to give them multiple ways that they can go in and they can actually access the course. And then from here, once again, I can click right here. This is all the activities that you may have been using already. So if I select that, this just takes me to the activities page right there. Okay, and then finally, I can also get there from the Learn button right there, right here. So if I click on that, it also takes me to cs.vex.com. Okay. Question about Python. Python with VexCode VR and Python support. Once again, we will be, our next course will have Python in it. So the next course that we're going to have coming in 2021 we're going to cover some more higher level topics like functions and variables. We're going to stay in blocks to do that. But then we're also going to cover the transition from blocks to text. So we're going to go ahead and do that for you. And then we're going to go ahead and have another course that's just on Python itself. So just let me go ahead and show that to you. The reason why we have that What's New button, by the way, is because a lot of people don't realize right now that Python is in VexCode VR. So I can open up the Code Viewer button right there. And when I open it up, you can see that I have the Python commands right over here. So if I go and I add a block, I'll add a turn right command. That command will be added in Python right there. So this is a great way in order to be able to introduce computer science or Python to your students. And we'll have this all structured in a way that'll be really effective for you to be able to teach this. If I wanted to, I can just start a new Python project right now. Okay. And there I have it right there. I can go and I can drag the commands in just like I could with blocks. We have a really great autocomplete feature located in here also. So a lot of really nice things in Python. Okay, so more information about that upcoming. Thank you for joining me this evening for our webinar. Once again, we are really, really excited about this course. We can't wait to hear your feedback about the course. You can send me emails with your feedback, or you can contact me on Twitter. Use Vex social media. We would love to hear what you think about our Computer Science Fundamentals course. Once again, it's free. VexCode for this school year, VexCode VR will also be free for this school year. We want to help you trying to teach computer science this fall. We feel like VexCode VR is a great way to teach computer science. Robots is a great way to teach computer science. So once again, we can't wait to hear what you think because we love the course and we can't wait for you to use it. Thank you for joining me here this evening. Have a great night and we'll talk to you soon. Thank you.